Hello! Today we're going to be talking about how to convert from different forms of a quadratic equation, which so far we've talked about three nifty forms. The first one being standard form, which is that ax squared plus bx plus c. Factored form, which is when you have like a parenthesis times a parenthesis, because when you have factors, that is when you have more than one value being multiplied together to equal another value. Alright, and then we have vertex form, which is the form y equals a times x minus h quantity squared plus k. Okay, so we're going to learn how, when you start with one of those forms, to convert to the other two forms, which we're going to be working through three examples, which all three of these start from a different form. So you're going to learn how you can start from each of the three separate forms and how to get it to the other two forms. Okay, well, I'm already really pumped up. So let's get started on example 1. Let's do it. And I really hope my document camera isn't frozen. Thank you. Okay, so let's get going. So, on example 1, which actually I'm going to cover up some things. Alright, but anyways, so again, we're going to be converting to different forms of a quadratic equation, which again, standard form is that ax squared plus bx plus c. Factored form is when we have more than one value multiplied together, so when you see like two parentheses side by side. And then vertex form, which is the a times x minus h quantity squared plus k. Okay, so in our first example, we're starting off with y equals negative x squared plus 5x plus 6. So, first of all, I need to know which form we're starting with, so then I know which forms we need to convert it into. Okay, so which one of these forms does example 1 kind of look like? What would you say? Would you say it's standard form, factored form, or vertex form? Holy hot dog. I don't know why I teach you guys. You guys are always on point. Okay, so in example 1, this is in the form ax squared plus bx plus c, which means we're starting from standard form. Okay, so we're starting from standard form, which means we need to convert this thing to the other two forms, which is factored form and vertex form. Okay, so I'm going to show you how to do each of these forms. Now, it really doesn't matter when you start from standard form. It doesn't matter which form you decide to tackle first. Okay, so you could do either factored form or vertex form. It doesn't matter. Now, some of the other forms, when you start from factored form and vertex form, it will matter which one you start with first, but we'll talk about that when we get there. Okay, so I'm just going to rewrite this equation real quickly. Alright, so we have negative x squared, and then we have plus 5x, and then we have plus 6. Okay, so if I'm trying to get to factored form from standard form, guess what I'm going to have to do? Well, it's kind of in the name. I need to factor my equation to get it into factored form. Okay, so in order to do this, you're going to have to factor. Now, technically, you could do the quadratic formula or complete the square, but when you do completing the square or the quadratic formula, you actually get the zeros of your quadratic equation. So if you get the zeros, you just need to make sure you write it in factored form, which I'll kind of go over that. I'm going to show you how to do it through factoring, but I'll kind of explain what you would do if you chose to do the quadratic formula or completing the square. Okay, so the first step, whenever you're trying to factor, what do you always try to factor out first? That is the GCF. And don't forget, you guys, what should your leading coefficient always be before you start factoring? It should be positive, which currently it's negative. Oh no. Okay, so what do I need to factor out in addition to the GCF to transform that negative leading coefficient into a positive? I would have to factor out a negative. Okay, so before I do that, secretly, since I don't see a number in front of the x, there's secretly a negative 1. Okay, so what is the largest number that will divide into 1, 5, and 6? Well, that would be a 1. Okay, so 1 is my GCF, which normally 1, we don't really do anything with if it's the GCF, but since I have a negative leading coefficient, I need to make sure I factor out a negative 1. Okay, so if that would have just been a 1, then I wouldn't need to factor out GCF. There'd be no point. You could, but it wouldn't really do anything. Okay, so my GCF is going to be -1. Okay, so I'm going to factor out that thing first. So I'm going to divide every single term by -1 and write what's left over in my parenthesis. Alright, so -1 divided by -1 is +1. So I have a +1 x squared. 5 divided by -1 is -5. So it'd be -5x. Okay, and then 6 divided by -1 is -6. Okay, you guys, so since we have 3 terms and we have a quadratic, so now I'm looking in here. Because I have 3 terms in a quadratic, remember you ask yourself, can I keep factoring after you factor out the GCF? And we always hope we can because we love to factor. Okay, so since I have 3 terms in a quadratic, which factoring technique do you use to factor the quadratic? You would general factor. Okay, you're going to use general factoring, which again, there's lots of ways to general factor. Okay, I'm going to show you how to do it through slide and divide, but again, if you hate slide and divide, you don't have to do it. Okay, it's up to you. Okay, so I'm going to start setting up slide and divide. So remember, we need to find 2 numbers that multiply to be AC. So we'll hold on. Sorry, I like to be color coordinating, and I didn't color code my equation. Jeez Louise. Sorry, guys. That's supposed to be yellow. Sorry. So we want to find 2 numbers that multiply to be AC and add to equal B. Okay, so let's do that first. So, A times C, I'm going to slide A to C. Okay, so 1 times -6 is -6. Okay, and then I want to find 2 of the same numbers that will also add to be B, which B is the -5. Okay, so I need to find 2 numbers that will multiply to be -6 and add to be -5. Now, before we do that though, okay, usually you guys, I'm awful about remembering things. Okay, so we know we're going to get like something like this when we get done. Remember, it is called slide and divide. So we slide by the A, and don't forget at the very end, we divide by the A. So A is 1, so I'm going to divide by the 1. Okay, and then also don't forget to write your GCF out in the very front. Okay, so I'm going to do all that before I forget, because you know Miss Long, she's really forgetful. So I'm going to do that before I forget. Okay, now back to what we were talking about. So I need to find 2 numbers that multiply to be -6 and will also add to be -5. So let's see here. Some things that multiply to be 6. Well, first of all, you guys, don't forget, since we're multiplying to being a negative, one of these numbers will have to be positive, and one of them will have to be negative. So I'm already going to get that ready. Okay, so let's see here. Well, 1 and 6 multiply to be 6. Let's see if that works. So 6 minus 1 is +5, but 1 minus 6 will give me -5. So guess what, you guys? I think I just found it. I'm pretty good at guessing now. I've been working on it. Okay, so it looks like 1 and 6 would work. Now, you could try 2 and 3. 2 times 3 also multiplies to be -6, but 2 minus 3 is -1, and 3 minus 2 is +1. So, although you can multiply 2 and 3 to be 6, it would not work to give you a -5. So, keep that in mind. Okay, so what is going to work is when we have -6 and a +1. 1 times -6 is -6, and 1 plus or 1 minus 6 is -5. Yes, we figured it out. Thank you guys for your help. You're always very helpful. Okay, so now I'm going to bring these numbers on down. Since we have a +1, I'm going to add the 1. And since we have a -6, I'm going to subtract the 6. Okay, and then the last step that we have to do is just to simplify. And then guess what, you guys? We'll be in factored form. Yes. Okay, so now what I'm going to do. So we have y equals -1 times 1 divided by 1 is 1, so x plus 1. And x, or a -6 over 1 is -6, so we have x minus 6. So guess what, you guys? We factor till we can't factor anymore. So guess what? we have reached factored form. So this is my factored form of the quadratic equation. Okay, so just be careful. If you guys did the quadratic formula or completed the square, first of all, you have to remember that your a value goes in front. Okay, your factored form, a value goes in front. Okay, so just make sure you write the -1 in front. If you did the quadratic formula, if you would have solved, you would have gotten like x equals -1. So don't forget, when you go from your parenthesis into your zeros, remember you flip the sign. So when you do the quadratic formula or complete the square, you end up with your zeros. You end up with something like x equals -1 and x equals 6. So if you did the quadratic formula, you would have to flip the signs to get it back into factored form. So just be careful, you guys. Again, it's not wrong to do the quadratic formula or completing the square. Just know you're not in factored form anymore. You have found your zeros. So you just need to make sure you convert your zeros back into factored form. Okay, well guess what? That is factored form. Yes. Okay, so now switching gears. Now we're going to talk about how to convert standard form into vertex form, which looks like this. Guys, so for vertex form, all you need, don't forget, you keep the y and the x, okay, but you need to fill in the values for the a, h, and k. Okay, so once you know the a, h, and k, you're golden. You just fill them into the correct spot. Okay, so I'm going to kind of set up vertex form. Alright, so we need the a value, so I'm missing an a. I need to fill in the a. We're missing the h, and we're missing the k. Okay, so once I find the a, h, and k, I just need to slide them into my equation, and then we'll be done. Okay, now the a value is always super easy to find. The a value in vertex form is the same as the a value in standard form. So looking here, what is the a value? Which if you want to look back here, you can as well. Well, the a value is the number in front of the x squared, which since we didn't have a number, remember there's secretly a 1. So the a value is -1. So I'm going to put -1 in the a spot. So this will be -1. Okay, so a is done. Now I just need to find my h and my k, okay? So I'm going to go ahead and rewrite vertex form. Rewrite standard form so then I can solve for the vertex point. Once I know the vertex point, which is the h and k, I just need to slide those bad boys into my equation, and then I'll be done. Alright, let's get started setting it up. So we have -1x squared plus 5x plus 6. Okay, so if you recall from standard form, the way that you find the vertex point, well, first of all, the way that you find your h value, the h value of your vertex point is the same as your axis of symmetry equation. So if we can find the value of the axis of symmetry, then guess what? We know the h value. Okay, so let's get started. Okay, so my axis of symmetry equation, we have x equals the opposite of b over 2a. So the opposite of b over 2a. Let's solve this thing. Okay, so that will be negative, the opposite of b, I guess. So the opposite of +5 is -5 over 2 times a, which a is -1. Okay, so we're going to have -5 over 2 times -1 is -2. And guess what, you guys? A negative divided by negative is a positive. So my h value will be a positive 5/2. And if you guys realize I wrote the h and k in different colors, but it'll be okay. Okay, so the axis of symmetry, this is our h value. Okay, so this is the h value of our vertex point. So the h value is going to be 5/2. Okay, now, don't forget, you guys, in our vertex point, the h value is the opposite sign as whatever it is in the equation. So you must think the opposite with the h value or flip the sign. Okay, so since I have a positive 5/2 here, I'm going to write this as a negative 5/2 here. Okay, and we're just going to leave it as a fraction because in vertex form, this tells me my vertex point. So you could technically like slide the 2 in front of the x. Okay, but then you wouldn't really know the vertex point. So when you're in vertex form, that's the only time that fractions are okay. Okay, if you're in factored form, that would be a no-no. Okay, so just keep that in mind. Okay, so we found the h value. Now I need to find the k value. Which, do you guys remember how we find the k value? Of course you remember, because you always do. Okay, the way that you find the k value, okay, remember this is the h value or the x value of the vertex point. So if you have an x value, the way you find the y value, which in this case is the k value, is by substituting it in for x. Okay, so to find the k value, I'm going to replace every single x with the 5/2 and solve for y, which y is going to be the k value because the k is in the y spot of the point because it's the second value. Okay, so let's start substituting this in. And it's going to be okay, you guys. Fractions are our friends, so it's going to be great. Okay, so we have -1 times x squared. So this x is going to transform into a 5/2. So this will be 5/2 squared. And then we have plus 5 times x. So that x will transform into a 5/2. And then we have the plus 6 on the end. Alright, well let's solve this for y, because then we'll have our k value. Okay, so we have y equals, now, don't forget, in order of operations, would I do -1 times 5/2 then square it? Or would I do 5/2 squared then times -1? Well, you have to do exponents first. So I'm going to do 5/2 squared, then multiply what I get by -1. Okay, which if you guys remember the shortcut, if you have a fraction squared, you just square the numerator and denominator, and bam, you're done. Okay, so 5 squared, 5 times 5 is 25, over 2 squared, 2 times 2 is 4. Okay, and then here, when I multiply two numbers, I need to go straight on across. And don't forget, it might help you to write 5 as a fraction, so we can kind of multiply it as a fraction. So 5 is secretly over 1. Okay, and then I'm just going to multiply straight on across. Okay, 5 times 5 is 25, and 1 times 2 is 2. Okay, and then I'm just going to bring on down the 6 for now. I'm going to rewrite 6 as 6 over 1. Since I already see we're going to have fractions, I'm going to kind of prepare us. Okay? Okay, so -1 times 25 over 4 is -25 over 4. Okay, and I'm going to start setting this up to add. Okay, I see that my next two denominators have a 2 and a 1, and my current denominator is a 4. Don't forget, you guys, when you add fractions, you must have a common denominator. So what is the smallest number that 1, 2, and 4 will multiply to equal? My common denominator would be a 4. So I need to make sure both of these denominators are 4. So I'm going to go ahead and set that up to kind of save some work for me. Okay, so I need to think about, well, what do you multiply to each of these denominators to get a 4? So 2 times what gives me 4? Heavenly hamburger, that would be 2. Which, don't forget, if you multiply it to the denominator, you gotta multiply it to the numerator. And then 1 times what gives me 4? That would be 4, which if I multiply it to the bottom, I gotta multiply it to the top. Okay, I'm going to go straight across, which I don't have a lot of space, but I am multiplying straight across. Okay, so now I'll be set up to solve. Okay, so we have plus 25 times 2 is 50, over 2 times 2 is 4, and then plus 6 times 4 is 24, and 1 times 4 is 4. Okay, so let's start adding this. Okay, so don't forget, you guys, when you add these up, okay, you leave the denominator alone. Don't touch the common denominator or the demon cats will get you. Watch out. Okay, so let's add all the numerators now. So -25 plus 50 is 25, and 25 plus 24, well, that's going to give us 49. Okay, so my y value, which is technically my k value, is 49 over 4. So for the end of my vertex form, it's going to be plus 49 over 4. Okay, which I know that kind of looks a little weird because it's like all like wavy. Okay, so if you want to rewrite vertex form, you can. I'm kind of out of space though, but I can be creative. I'm going to like write it sideways. You guys leave space though so you can rewrite it again. Okay, so our vertex form is going to be y equals our a value, which if you look sideways, you see it's -1. So you can put -1 or just a negative, it's up to you. Typically, mathematicians are lazy and they don't write the 1, so I'm not going to write it, so you'd be used to how a mathematician would write it. Okay, so it'd be negative times x minus 5 halves, quantity squared, and then plus 49 over 4 if you turn your head sideways. Sorry, I know your neck's probably cramping up right now, I'm sorry. Plus 49 over 4. And guess what, you guys? That's our vertex form. Look at that. Oh man, my marker's dying on me. Don't do that. Ah! Okay, there you go. So we have vertex form. So that's the vertex form of my equation, and this is factored form. And that would be our standard form. So all three of these forms are equivalent, which is really cool. Nice work, you guys.